this, with regular functions, is how we write inverse notation. So if we find the inverse, we use that little f negative 1. And that's for the algebra side, the pre-calc side. But now that we're in trig, we have to think about inverse functions and what it actually means if we're trying to find an inverse. And when we're finding inverses, we'll be finding angles. Every time you plug that sine negative 1 into your calculator, the answer that it popped out was an angle. Whether it was in degrees or radians, that just depended on your calculator and the function that you had it in. So it says the angle whose sine is x. So we're going to have a number, and we're going to calculate sine, and our goal is to find an angle that corresponds to the sine of this specific number. There are 4 different ways to write that, and the first one is the way you usually plug in with your calculator. And this could be sine, this could be tangent, this could be cosine. I just picked sine because that's the first one we're going to look at. So sine negative 1 really means we're finding an angle whose sine has this specific x value. Another way of writing it would be actually like an equation notation. So that means the angle whose sine is x. So the little inverse part means we're finding the angle. I want to find an angle who has a sine value of whatever number we're working with. The third one, because there's really 4 different ways we can look at it, uses the word arc. Because in trig, you can't just be like, let's put a little negative 1 with it. We have to say, hey, let's throw in an extra word. So if you see the word arc sine, arc tangent, arc cosine, that's another way of saying inverse. So this is a trig term there that refers to the inverse function. So the inverse of sine, we say arc sine. The last one kind of applies a property of inverses. So if you, again, take your brain back to September, and I just give you the algebraic equation y equals 3x. What do you do to find an inverse equation? What's the process that we do? Brandon?
We do the opposite equation, so instead of multiplying x by 3, divide by 3.
Okay, and do you remember like what else you did in that process? Virginia? Yeah, you switch x and y. So like to do that, Brandon, you're totally right. We would usually flip-flop x and y, and then we got y by itself by dividing by 3, and Brandon, then you have your opposite equation. So you said you were multiplying, and now we're dividing. But you got there because we flip-flopped x and y. So to get that final equation, I'm going to come back up here to this equation. If I follow that thought process and flip-flop x and y, then I should be able to take it out of inverse notation. So if I take it out of inverse notation, I would have x equals the sine of y. So that's by using that flip-flop property where I can switch x and y. So switching it to go back into the regular function. We're going to be trying to use that property today to help us evaluate. So the first thing that we're going to do, after kind of knowing what to look at, what the notation is going to look at, is we're going to try and graph. And the reason we're graphing is because I want you to see why it's created and where it exists. So the first thing that you're asked to graph is the regular sine graph, which we've been graphing since mid-November, or mid-December, not mid-November, mid-December. So we're going to graph y equals sine of x, regular sine of x, no phase shift, no a value, no d value. It says to graph it from negative 2 pi to positive 2 pi, negative 2 to positive 2, scales of pi over 2 and 1, which is exactly how we've graphed it every single time we looked at one of these functions. So the x-axis, count by pi over 2. The y-axis would be those integers. And then getting that mental picture that hopefully is in your brain for sine. So sine goes up and comes down. It has that nice hill and valley, that nice wave movement in the graph. So thinking about those 5 key points, sine starts at 0, 0. You need to write those 5 key points. If you don't have to, that's fine. But remember, you're plotting the sine graph. So if you like have that shape memorized, you know where your points are, don't need to write the 5 key points, that's fine. And then I'm going to graph the second period because it asks us to graph it from negative 2 pi to positive 2 pi. We always should have that hill, valley, hill, valley, hill, valley, that nice rolling wave. So underneath, a little review of what a function is versus why a function has an inverse. First question says, what test must a relation pass, which is any graph. Any graph has a relation, a mapping or an ordering of ordered pairs. So what must a relation pass in order for it to be a function? Kate? The vertical line test. And I don't know if everybody knows Kate, sorry, I'm like now calling you out. Kate's in our class, she had a schedule change. Alice also had a schedule change, so Alice moved to 7th period. Kate's coming to our class. So, hi Kate. Make her feel welcomed and loved. Brandon?
You can't do that.
No?
No.
Yes, all the time. So, vertical line test. Is this sine wave a function? Does it pass the vertical line test? Yes. All right, the second question, what test must a function pass? So once we say yes, it's a function, what test must it pass in order for the function to have an inverse, Kate?
Horizontal.
The horizontal line test. Nick, does this pass the horizontal line test?
No.
No. As the horizontal line test means you draw a horizontal line, and if it passes through your graph more than once, it will not have an inverse. So right now, our beautiful sine curve, which mine looks pretty darn good right now, although I guess the one curve is a little lower than the other, it doesn't have an inverse. So, math people don't like when things can't work. We always try to find a way that it can. And again, back to chapter 1, we had this beautiful parabola. Does a parabola have an inverse, Nick?
No.
No, it doesn't. This doesn't pass the horizontal line test still. Does anybody remember what we did to the parabola to force it to have an inverse? Okay?
Split it in half.
Yeah, we split it in half. So we either looked at the right half, which pretty much started where the vertex was, or we looked at the left half. So instead of saying, okay, I have this whole parabola, we took a piece of it. It still represents the equation, but it only has half side of it, part of it, so now it has an inverse, because now it passes the horizontal line test. So we're going to try and do that exact same thing with the sine graph. We're going to force it to have an inverse by picking a special part of it. Now I can't take half of it because the graph goes up forever. It continues to just go up and down and up and down. So we're going to see if we can try and pick the part that would have an inverse. And generally, we start at 0, 0, which if this parabola was at 0, 0, we pick the part that starts at 0, 0. So if you start your graph at 0, 0, trying to start at the origin or on the unit circle at the angle 0, and we move to the right as far as we can go because a graph starts at the left and it moves right. So we're traveling up to pi over 2. Libby, if we pass pi over 2 and go down to pi, is it going to continue to have an inverse? No. So it has to stop at pi over 2. But if I go back to 0, 0, and move in the other direction as far as we can move until it no longer has an inverse, now I have a portion of the graph. So picking a piece of the graph that would have an inverse, or that goes from a distance until it no longer passes the horizontal line test. And that happens from negative pi over 2 to positive pi over 2. So I'm going to erase mine. You don't have to erase the rest of yours, but make sure that you're highlighting the piece that has the inverse. So now I've taken this sine function, and we've just taken a piece of it. We're no longer using the whole thing, we're just using this little portion for sine. And that portion that we're using goes from negative pi over 2 to positive pi over 2. So it says we limit the domain to force it to pass the test. And this is where we're limiting our domain. So we're limiting it just to the values of negative pi over 2 to pi over 2. So that means when you go to find an answer, which is really an angle, your answer can only be from negative pi over 2 to pi over 2. So if you say 2 pi over 3, wrong, because 2 pi over 3 is bigger than pi over 2. If you would say negative 11 pi over 6, again, you're wrong, because negative 11 pi over 6 is past negative pi over 2. So the angles can only be in between those two values. All right, so now we're going to try and graph this inverse. So when you graph an inverse, we're going to take the ordered pairs, and now there are only 3 of them. We only have 3 ordered pairs to work with. So we have this ordered pair at negative pi over 2 and negative 1. We have an ordered pair at 0, 0, and an ordered pair at pi over 2 and 1. How would you use those 3 ordered pairs to graph the new function? Sabrina? Yeah, so we're going to take those 3, swap x and y. I like that word, swap. So the first point is now negative 1 and negative pi over 2. We still have 0, 0, because you can't really swap those. And then we have 1 and pi over 2. So notice now your x values are 1 and negative 1 instead of being angles, because we switched x and y. The y values are now the angles, so negative pi over 2, positive pi over 2. And then you've got 3 points to plot. All right, so the last part is just as important. We have to figure out how to connect the dots. And there's one final thing, that when you have a graph and its inverse, there's supposed to be something special that happens with the graph and the inverse. They're supposed to reflect over a line. Yes, and Kate was drawing like an air drawing. So they're going to reflect over that y equals x line. So if I could draw in a line for y equals x, they should be reflections or opposites of that. So this first part here has this type of curve, so when you go to connect it, you need to make the opposite curve. That makes it a reflection over y equals x. So an inverse has a couple properties that we just kind of reviewed. So the notation, how to find it, switch x and y, how to graph it, get those points, switch x and y, but then you need to reflect it. So your graph doesn't look exactly the same, it should be a reflection of the graph. Questions? So if you just try and look at the questions below, they are based off of this graph that we have. So now that we have it sketched, it says, what is the domain of this function? So now that we have the inverse function, what is its domain? Negative 1 to 1, and that's it. It starts at a point for negative 1, it goes to a point at positive 1 on the x-axis. What's the range? Right. And again, it has no more. Like those are points on the graph, it doesn't go above or below those points. And then the last 2 questions, I think, go back to sine. So the domain of a regular sine graph is negative infinity to infinity. That's the whole sine graph. We use this over here, which correlates with the range, because we shrunk it. We only picked a piece of the graph. So the domain of your function should be the range of the inverse. And then the same thing here, the range of my function should become the domain of the inverse. Because x and y flip, domain is x, range is y, so they should flip as well. So these top 2 things here, star those, box them, you've got to look over those. That's where the memorization part comes in Trig. There's all these stupid little things to memorize, because that's probably the word you're thinking of, stupid little things. But in order for an inverse to exist, it has to meet these restrictions. Questions? And that's for sine. So we got sine done. So if you flip the page, there are 3 examples just to give you an idea as to what you're doing for your homework. Because once the graph is there, it's the same graph every time. So you're not going to be asked to graph it again, because the graph isn't going to change. So instead, that 5 to 13 is going to look similar to the problems on this page. So it said, find the values of the following. No calculator. And we have arc sine, which is another way of saying inverse. And then in parentheses is the value of negative 1/2. Now, this is a thought process. No, you don't need to write this for every single problem. You're going to have to show me a little bit of work as to how you're getting the answer, but like this is just to give you an idea of what we're thinking about. So it says, what should you think? Well, our goal is really to find an angle, because that's the answer of an inverse function. We're finding the angle. That has a sine value. What angle has a sine value of -1/2? That's really what the question is asking. So when it says arc sine or inverse sine, the question is really saying, even though it's not talking to you, what angle has a sine value of -1/2? The second part says write the equation. That's what you're going to have to do for some work. So we're going to take this inverse and we're going to pop it into equation form that we've used before. This is really equal to the angle because that's what we're trying to find. So if I write that as an equation and we flip x and y, we would now have the sine of some angle is equal to -1/2. This is an equation that we worked with in chapters 4, or the beginning of chapter 4, sections 4.1 through 4.4. So we're finding an angle where the sine is -1/2. Now it says think some more. So this is the part that I want you to kind of remember the angles that we're thinking about. We can only be between pi/2 and -pi/2. It's not allowed to go in the second quadrant. It's not allowed to go in the third quadrant. So this goes back to the unit circle. So you need to take your brain, go back to the unit circle. Let's start with the family of angles. So if we have a sine being 1/2, what family of angles, Michael, has a sine of 1/2?
5/6.
And how did you know that?
Well, that's what
Oh, you're awesome. Which value on the unit circle is sine? The y. So this is my y value on the unit circle. So that's kind of a thing to remember. Sine is y. So on the unit circle, when do you have a y value of 1/2? And he said pi/6. All right. So now that we know that family, so that's our family of angles, Michael, is pi/6 going to be in the first or the fourth quadrant because it's really a negative pi/2, or -1/2, I'm sorry.
It would be in the fourth quadrant.
It's going to be in the fourth quadrant because sine is positive in the first, negative in the fourth. And then we need to get the angle that goes in the fourth quadrant.
5/6.
That'd be the second one. Libby?
Is it 11pi/6?
It would be 11pi/6. So don't write this down yet, but just kind of show you. So if it was 11pi/6, here's 6pi/6, and then this would take us to 11pi/6. What's wrong with 11pi/6? Brandon?
It's greater than pi/2.
It's greater than pi/2.
So would it be negative?
So it's just going to be the negative pi/6. It's just the negative angle because it can't be bigger than pi/2. So I can't use 11pi/6 because it goes into the second and third quadrants. And essentially those quadrants are like the black hole. They're gone. So if you step into those, you fall and you never come back. But if we move the opposite direction, it's the same exact angle, but it gets us into the fourth quadrant without going through that other location. Questions? Living.
So in our homework, when we show the work, could we basically just do the graph? or-
Yep, so this equation and the graph, that's it. That's all I need. So if you look at the second one, there's another one underneath. It uses the inverse notation instead of arc, but it's asking the same question. So what angle has a sine of square root of 3/2? The equation, if you think about this being equal to the angle, would be the sine of some angle equals the square root of 3/2. You don't have to draw the diagram again, it's already above, but I'm just drawing it to show you kind of notation here. I always just like cross out the quadrants it's not allowed to go through. That way visually, if I'm trying to find that angle, I need to make sure it doesn't pass that location. So again, on the unit circle, what angle has a y value of the square root of 3/2? Brandon?
Pi/3.
Pi/3. So Brandon, what quadrant do we need that angle to be in?
First
The
quadrant.
first quadrant. Because sine is positive in the first quadrant. So our answer would be pi/3. more memorization. That's on that memory bank. And the multiple trig pieces of information and facts that you have in there now. So there's one other question underneath. And again, like this could change. We would do the same thing if it said cosine. We'd do the same thing if it said tangent. So you're approaching the problem the same exact way. Every single one of them are trying to find the angle. The last one says the inverse sine of negative 2. So one final time here. What angle has a sine value? Of 2. Inverse sine of 2. So write the equation. I want to find an angle for sine, and it's equal to 2. Then it says comment, and then it says, how does your calculator handle this? Anybody have a comment? You're supposed to.
There's no number next to the circle.
Why not?
Because we only do it whenever the radius is 1.
He said we only have values when the radius is 1. This guy here is y. Well, our range just goes from negative 1 to 1. So this is undefined. There isn't an answer. Sabrina, you have a calculator on your desk. If you plug in the inverse sine of 2, so it's sine negative 1 of 2, what does your calculator say? Say it again?
Nothing appears.
Nothing appears? Like nothing?
Yeah, nothing.
Oh, wow.
Your calculator says like, no, not doing it.
Yeah, like forget you. I can't even try this. Sometimes it might say like error domain. I can't believe nothing appeared. So the calculator, either nothing appears or it'll say error. It'll tell you I can't do it. Just like when you divide by 0, it says you can't do it. So if this number is bigger than 1, smaller than negative 1, there's not an answer for sine or cosine. Questions? Brandon, what'd you say?
Mine said error.
Error? You specify it.
Well, I think something over 0 and nothing appears as well. So
Oh.
I guess it's a
Huh. That's its way of answering. All right, so what we're going to do on the next 2 pages, so we've just done 2. I said we were going to at least cover 4 pages, because we're just going to graph. So we're going to see how does the cosine graph work, how does the tangent graph work. So if you could see, if you can try and graph the cosine, same way we graphed sine, so just y equals cosine x. You're labeling it the same exact way. Bless you. I erased my graphs, so I have to make sure I grab them. So our nice little cosine graph starts up at 1, in the middle at pi over 2, the lowest point at pi, and then it works its way back up to 2 pi. So yes, it passes the horizontal line or the vertical line test. It needs to pass the horizontal line test in order for it to have a function. So the question then becomes, what section of the graph do we use? Michael?
From 0 to pi.
Awesome, yeah. So he said from 0 to pi, because again, we try and start at 0 and move forward as far as you can. Well, if you start at 0 and move to pi, it passes the horizontal line test from that portion there. Nice, Michael. So that last question, 0 to pi. So then we're going to take those 3 points and see if we can translate these points to get the inverse function. So I have a point at 0, 1.
Good afternoon, and please pardon this interruption. Tomorrow is the last day to sign up for the ski trip to
Flip-flop those points and take those 3 ordered pairs and flip
Payment
them.
and forms are due by January 23rd. Please stop in the athletic office to sign up and get more information. Also, EEC will be in room A113 beginning at 2:05 today. Thank you.
So I just took the x values and the y and flipped them. Did the same thing with my axes. So the y values are now on my y-axis, and I had values of pi over 2 and pi. The x values, which were over there, as y values, they're now my x-axis. So we have a point at 1, 0, because it was 0, 1. At 0, pi over 2, and then at -1 and pi. When you connect these, remember each piece has to do the opposite. So look at the curve that you have. That curve has to be the opposite direction. They should be reflections. So the domain of this graph is still -1 to 1, because the range of cosine is -1 to 1. The range of the inverse is now from 0 to pi. That's the restriction that we made, from 0 to pi. These 2 pieces of information are a little different than sine, because we restricted a different area. And then the cosine regular domain, -infinity to infinity. The regular range for cosine, -1 to 1. All right, so really quickly, I'm going to try and get the tangent graph in. So the special thing about tangent is that it has asymptotes. And I'm just going to graph from pi over 2 to pi over 2. So at -pi over 2 for tangent, we have an asymptote. At positive pi over 2 for tangent, we have an asymptote. I'm just going to graph those 2 to try and save us 2 minutes here. In the middle, we have an intercept. And then halfway in between pi over 2 is pi over 4. We have a point up at 1. Halfway in between -pi over 2 and 0 is -pi over 4, or sorry, -pi over 4. And we have a point down at -1. So your tangent graph is an increasing graph. This is one section of the tangent graph. So the tangent gets limited to -pi over 2 to positive pi over 2, but those are parentheses because of the asymptote. So taking my 3 points, I have a point at -1 and -pi over 4. I have a point still at 0, 0, and a point at +1 and +pi over 4. So Brandon, if we have vertical asymptotes in our function, what will happen with those asymptotes when we make our inverse?
They're gonna be horizontal.
Right. So we now have horizontal asymptotes. Instead of being at -pi over 2 and pi over 2 vertically, they're now horizontally. There's still a point at 0, 0. 1 pi over 4, -1, -pi over 4. apologize, I went through that. So this domain is negative infinity to positive infinity because it goes on forever. It skims along the asymptotes. But the range is the negative pi over 2 to pi over 2 with parentheses instead of brackets. So your homework looks like that arc sine, arc tangent, arc cosine. You're finding an angle as a solution. So that's the key thing to remember. You're really finding the angle. Anybody interested in trying 9A or 10A to start the new semester? Nick, 9A. Sabrina, 10A. Awesome. Have a wonderful day.